Hello, we are on lesson 71, 5th grade, lesson 71, and we're trying to find, what is it called? It is called parallelograms. And then there's a few properties of parallelograms when it comes to angles that will help you when figuring out angles of the parallelogram. So in the book, it has this example of a parallelogram with A, B, C, D. So this is called parallelogram A, B, C, D because that's how many vertices, what the vertices are named, A, B, C, D. So in this lesson, we'll learn about various properties of parallelograms. The following example describes some angle properties of parallelograms. So our first angle property of a parallelogram is that the opposite angles of a parallelogram have the equal measures. Equal means the same. So this angle here is the same as what? What's the opposite angle of A? It's not B because that's right side by side. The opposite angle of A is right straight across from it. So the angle of A is equal to angle C. How about B? What's the opposite of angle B? Well, right straight across from it is D. So this angle right here is the same as this angle right here. That's just an angle property of parallelograms. If this said, X, Y, Z, so X would be the same angle as Z's because it's right straight across from it, okay? And then adjacent, do you know what adjacent means? It means side by side. This angle and this angle are adjacent angles because they're side by side. D is an adjacent angle to C because they're side by side. Okay, so in the book it asks us, in parallelogram A, B, C, D, what is the measure of C? Now it tells us the measure of A is 60 degrees. 60 degrees. If we use our little protractor that we had in class, we would know that angle is 60 degrees. But it's asking us what the measure of C, what the measure of angle C is. And in a parallelogram, opposite angles of a parallelogram have equal measures. Equal means the same. So what is the opposite angle from A? C. So this angle C is also 60 degrees because they have equal measures. Okay? How about B of example 1? We're on page 379. What is the measure of angle B? Well, that's a tough one because it doesn't tell us. But you know what it does tell us? It says the adjacent side-by-side angles are supplementary. And supplementary means two angles that are equal to the measurement of 180 degrees. So let's get a different color so you can see exactly. Angle A, this is angle A, and angle B are side by side. And these two angles, since they're side by side, they're supplementary, which equals 180 degrees. So imagine that I have this angle A right here. This is angle A. Okay? This is 60 degrees. So since this is 60 degrees, what is this? It has to add up to, since it's supplementary, it has to add up to 180. So I'm going to take 180. Can you see that marker? Is it dark enough? 180, and I'm going to minus 60 from it to get the leftover so I'll know what angle B is. So I'll minus 60 from this. Okay? Minus 6, or 8 minus 6 is 2. 0. Bring down my 1. So it looks like I have 120 degrees left over when I take away my angle A. 60, this is 120. Do you see how I found that? I just minused, because I knew these two angles equaled 180, because that's what supplementary means. So I minus my 60 from my 180 and got 120. So what's the measure of angle B? 120 degrees. Okay? So what does it say? It just proves our point. We'll go to the next page. The next page has like a little flexible model of a parallelogram that you could make. It seems, let's see if I can bring it to you. It's telling you that even if you have a square, you see it? That even if you have a square and even if you tilt it, it's going to have the same perimeter. See, although It says, although you tilt it, the perimeter doesn't change. The area changes, but the perimeter does not. So the area, what the space inside changes, but the perimeter, the distance around the shape, does not change. Okay? And then it says the flexible model right here shows that parallelograms may have sides that are equal in length, but the areas are different. So to find the area of a parallelogram, we multiply two perpendicular measurements. So perpendicular, see how this goes straight like that across this one, and that's what perpendicular meant. Perpendicular is when you have a cross, straight line here, straight line across it. We multiply the base by the height of the parallelogram to get the area of the parallelogram. And this is the next activity that it wants us to do. And I have a little right here. There it is. I have one of our coordinate planes, an extra one. So I'm going to make my own. So it says materials needed, graph paper, ruler, pencil, scissors. So I'm going to trace over the lines of the graph paper. I'm going to draw two parallel lines, okay? The same units long, so the same number of squares long. So I'm going to write, I guess maybe I'll use a dark one. I'm going to use, you see it? I'm going to say 1, 2, 3, 4, 5. And then I'm going to shift it over because it's got parallelogram, so it has to be angled this way a little bit. So how much am I going to shift over? I'm going to shift over 1, 2, 3, 4. So I'll say, do I have enough room? 1, 2, 3, 4, 5. I'll start here. 1, 2, 3, 4, 5. And a parallelogram is two sides that are parallel. These two sides are parallel, and then when I connect, I guess I could use a ruler. I mean, I could use freehand, but I'll use a ruler. I don't have a ruler, so I'll use a straight edge instead. So I'll connect these two dots, right? And I'll connect these two dots, right here to right here. Boop. And now I have my own parallelogram. So the reason for this is to show you how it says to cut it out next, so I'm going to cut it out really quick. One side there. My beautiful graph paper just got cut. So sad. I'm going to cut this out. Cut this out in the line. Make sure it's nice and straight. Cut it out. Now, it says to make a perpendicular line. So straight up and down. Since this is straight up and down, these lines, and this line is straight up and down, it wants me to cut it in a perpendicular line. I could cut it here, I could cut it here. In the book, it goes over one square, and it tells us to cut it down this nice straight line. So I'll cut that in half. Let's see what it tells us to do next. Okay. You can always pause it if I'm going too fast. And then come back to it. So now I have my parallelogram, right? Let's see if we get a little bit lower, closer. So I have my parallelogram, and I have just cut a perpendicular line to it, straight up and down. Then it wants us to rearrange the two pieces of this parallelogram to form a rectangle. Do you want to try to do that without me doing it first? So go ahead and pause it so you can try to rearrange it to form a rectangle, and then you can press play again and see if yours matches mine. Because a parallelogram, when you rearrange it, how am I gonna, is that a rectangle? No. Is that a rectangle? No. How about up there? Is that a rectangle? That certainly looks like a rectangle to me. Looks like I might not have cut that perfectly straight though. Oh, I just didn't cut it. Okay. So it looks like when I rearrange it like this, it is a rectangle. See that? So a rectangle is how many units long? Well, 1, 2, 3, 4, 5 squares long. And then how many units wide? So there's long and wide. How many units wide? 1, 2, 3, 4. Okay? Before, when I had it in the parallelogram, oh gosh. How did I have it? Like this? No. Oh no. Can we make it back to a parallelogram? That's not it. That's not it. That's not it. How about like this? No. How about like this? Aha! That was our parallelogram, right? And I couldn't really tell how many units. There's 1, 2, 3, 4, and half of this one and half of that one. I guess that could be 5. And then 1, 2, 3, 4 up and down. But it's so much easier when you rearrange it so that this is like this to exactly tell what the area is, because you can just count it. Right? How many units long? You can tell exactly how much units long. 1, 2, 3, 4, 5. How many units wide? 1, 2, 3, 4. Okay? So remember I think I folded my paper that I used. But finding the area of a parallelogram, it said, and what it said finding the area of a parallelogram is the area inside. The area equals the base times the height. So that would be like, ooh, a little bit more. That would be, drawing our parallelogram again. Okay, that would be our base. This is our base. The bottom is the base, okay? And our height is how far up and down. It isn't this right here. It's how far up and down. Actually, it makes a square, right? That's what our height is. So sometimes it'll give us the height, and sometimes we have to figure out the height. But this formula is all that we need. The area is the base times the height, how tall it is. Okay? So there's some practice set problems that I would like to figure out, but there's an example 2 first. So in example 2, it says find the area of this parallelogram, and it has this shape and a little bit this shape, and it goes, and it goes, same. And this has 6 centimeters, and this on this side is 5.2 centimeters. And then it has this dashed line, and the dashed line is usually the height. It's shown as a height because right here it forms a perfect square. So the height, it says in our example 2, is 5 centimeters. And what's our formula for finding the area? Because it's asking us to find the area of this parallelogram. Well, there's this side, it's 5.2 centimeters. The base, this is the base, is 6 centimeters. And the height, up and down, this is the height, base, is 5 centimeters. So how do we find an area? The area, we don't know, but we know the base is 6 times the height is 5. So what is that? 30 square, because we're finding an area, square centimeters. Easy peasy? Okay, so let's go on to our practice set. And number 1 of our practice set says refer to parallelogram. Actually, it's A. Refer to our parallelogram. So this has a parallelogram that has 2 sides here, 2 sides there with a little bit of a slant and a little bit of a slant. Okay, and it says parallelogram. There's a Q, there's a R, S, and a T. So parallelogram, Q, R, S, T, or T, Q, R, S, or R, S, T, Q, doesn't matter. Refer to parallelogram to answer problems A through D. So A says, which is the opposite angle of Q? What is the opposite angle of angle Q? So which angle is opposite of angle Q? Remember, opposite means this across from, okay? It's not side by side, because this angle right here is way bigger than this angle. But this angle right here and this angle right here is exactly the same, because the properties of parallelograms when it comes to angles is the opposite angles have equal measures, the same measures. So what angle is opposite to angle Q? Well, the opposite of angle Q is angle S. See that? Okay, so B says, what's the opposite of angle T? Well, here's angle T. I'll use a different marker. Angle T is right here, and the opposite of angle T, right there, angle R. So the opposite of angle T is angle R. Okay? How about number C? Name two angles that are supplements of T. So here's angle T, but we want to know an angle that is a supplement. Remember, supplementary angles are angles that equal 180 degrees. So a supplement is one of those angles that paired up will equal 180 degrees. So it says name two angles that are supplements of angle T. So what is a pair? Angle T plus angle something equals 180 degrees. But it says two measures. So angle T plus angle something else equals 180 degrees. So let's see. This is angle T. And then remember the other property of parallelograms was the adjacent, the angle that shared a side, the side-by-side angle, were angles that were supplementary. Remember? So angle T plus angle Q, because imagine this angle right here, and you're moving it to right here, right? This angle is the same as this angle. So this angle plus this angle equals 180 degrees. But since these are the same and these are the same, then angle R is the same as angle T. And what's the supplement of angle R? Angle S. So we also know that angle S, it would be like taking our angle T right here, this angle, and putting it right here. This would also be an angle T. Okay? So since these are the same and these are the same, this adjacent equals 180 and this equals 180. Because remember, 180 just meant the two angles that made a flat line. So also angle T is a supplement of angle S because they equal 180 degrees. Okay? That was practice set. So how about if the measure of angle R is 100 degrees, okay, what is the measure of angle Q? Do you guys know how to do that? It would be like taking this angle Q and putting it right here. So if this is 100, and we know the angles side by side are supposed to equal 180 degrees, what is the angle of Q if R is 100? Well, 180, because angle R plus angle Q should equal, because they're side by side, they should equal 180 degrees. So we know the angle R is 100. 100 plus what equals 180? Well, I know that 100 plus 80 is 180. So it's asking us what is the measure of Q. Well, this is 100. That means this is 80 because they equal 180. Okay, it's just like a little puzzle. You got to figure it out. A little riddle. How about, goes on to letter E. Okay, we're on letter E now. Can you see that? Letter E says calculate the perimeter and the area of each parallelogram. So this one has a little parallelogram like this, down like this, straight line. And the side, this side is 12 centimeters. The base, the number on the bottom is the base, is 8 meters. Oh, this is not centimeters, this is just meters. And then it's telling us the dashed line. Remember the dashed line? The dashed line is always the height, forms a perfect square. And it's telling us that this is 10 meters. So what's the formula for finding the area of a parallelogram? Because it says in E, it says calculate the perimeter and area of each parallelogram. So we need to find the perimeter and we need to find the area. So what is the perimeter? Well, this side is 8. 8 plus 12. This side is 12. And since it's a parallelogram, that means this side's the same with this side, and this side's the same with this side. So we have 12 plus 8 plus another, same, 8. Oops, not centimeters. Plus another 8. And then this side is 12. That means this side is also 12 plus another 12. So what's that? I know 12 plus 12 is 24. I know 8 plus 8 is 16. So we have 24 plus 16. 6 plus 4 is 10. 2, 3, 4. So the perimeter looks like it is 40 meters. Okay, how about our area? The formula for our area, where is it? Looks like it's right here. Formula for finding the area of a parallelogram. Area equals the base times the height. Okay? The area equals the base. This is the base. Okay? The base is 8 times the height. Okay? Times the height is not 12, right? The height is how far up and down, perfectly up and down perpendicular. And it looks like the height is 10. So what is 8 times 10? 80, and remember we're finding the area, so it's 80 square meters. Okay? You guys get that? All right, let's see, is there anything else that looks kind of, oh yeah. You guys can do F, but I'm going to go on to G because it says the formula for finding a parallelogram is area equals base times height. This formula means the area is equal to the base times the height, but it tells us 2 parallelograms over here. It says, can you see across here? It says this one is the same. So we have this one, this parallelogram. It says the height, this is the dash mark, so you know it's the height. The height, it means a perfect square, is 6 centimeters. Looks like the base is 12 centimeters, and one of the sides is 9 centimeters. There's that one, but then it also has a second one. It says the base is the length of one side. Base is the length of one side. Okay? And it says the height is the perpendicular distance. So not the one that goes like that, but it's the one that goes into a perfect cross, like a intersection. But it also has this same shape, but in a different kind of angle. Okay? So this one has the height. Might not have done that straight as I wanted to. This side is 12 centimeters. This is the height, which we don't know because it just has an H, and a 9 centimeters. Okay, so it says the base is the length of one side. The height is the perpendicular distance to the opposite side. The height is the perpendicular distance from the opposite side. Here we show the same parallelogram in 2 different positions. So the area of the parallelogram is the same in both of these drawings. So it's asking us to find the height in the figure on the right. So if we know the area is the same here and here, I'm going to figure out this one first. The base times height. Area, what's the base? Side of a length of a side. 12 times, what's the height? The height is that dashed line, so 12 times 6. What is 12 times 6? Looks like it might be 72. Okay, 72. So that's the area of this. Now the area of this parallelogram is the same as the area of this parallelogram. So area equals base times height. Well, I know my base. Area equals 9. That's the length of one side. 9 times what will equal 72? 9 times what equals 72? Callie, what's 9 times what equals 72? 9 times 5 is 45. 9 times 6 is 54. 9 times 7 is 63. And 9 times 8 is 72. So right here, we know this is 8 centimeters. See how I figured that out? Because I had to figure out this one first so that I could just kind of fill in the blanks on this one. Okay? And that's the last one of practice set. So, I hope you had fun with that. I like these, but if you need extra practice, just call me and we'll do some more.